Hello guys, and welcome to my tutorial on depth first search in Python. So today we'll be creating some nodes, and then we'll be connecting them, and we'll find a path from point A to point B. So first, let me open up this sketchbook and show you what I mean. So imagine each circle here is a node. You can store data in it, but in this case there'll be no data. They'll just be labeled A, B, C, and D. That's a D. And these nodes are all connected in these lines here, and they're only single directional. They're not bidirectional. So you can go this way, but you can't go this way. So now what we will do is now we will just think about how we can go from our start, which is A, to the end, which we'll just make it D. So first, what we would do is, starting from A, let's create a tree. The computer will just go to its two children, which is B and C. And now let's just start with B. So with B you can go to C, and with C you can go to D. But since we're making a really dumb code right now, it'll just go all the way down here, and then it'll go up. So I'll show you what I mean. So then it'll be D. So obviously we know that this path is the shortest path, but the code we will write today will find this path because it's the first path that it finds, and we'll have it so it prints out the path. So you can pause it right now to understand this a bit more, but I think that should be good. So let's just open up a new Python file. I'll be using PyCharm as my editor, and now let's create a class, and we'll call this node, and in it, so if you don't know what I'm talking about right now, you should learn Python, the basics of Python. And yeah, because if you don't really know this tutorial might be a bit hard to follow along. And then self.name is equal to name. Okay, so what I did right now is, I just created a class called node, and inside of it I just gave two variables for each of the object. One is the name, so we'll just make it A, B, C, D, and the children. So the children is basically a list of all the other nodes that it's connected to. I'll show you what I mean right now. So now let's just start initializing our nodes. So we'll create A is equal to node, and it's just going to be called A. And for the children, we'll have an empty list. And B, do the same thing, and we'll have an empty list. C, and D. So right now I just initialized our nodes. Oops. And there. So all the nodes are initialized, but I haven't really gave anything for the children yet. They're all just empty lists. So, oh god, my bad. So what now we will do is we're going to actually start appending things to the list, the other nodes. So let's just look at this diagram to follow along. So, you know what? Let me just crunch it up. Okay, just need that. Okay. Sorry about this. Okay, let's just do that for now. So we're gonna have a dot is children, which is an empty list right now. Dot append, and according to our diagram, that should be B. And we'll just do the same thing. A dot children dot a append. Whoops. That should be a D. Okay, append C, and then we're gonna do B dot append. So B dot append. Oh, B dot children. Sorry. Append to C, and C dot okay, so now we have connected all our nodes together in this diagram right here. So what we'll now do is we'll create our search function. So let's just move this down a bit and create our search up here. So this is going to be a recursive algorithm, just so you know. We'll call this search, and we'll take current node and then our destination. Okay, and then we'll have a list. Well, right now we won't create a list, but we'll just find a path, and later in the tutorial we'll create a path. So now let's just go through all the nodes inside the children. So let's create a for loop for I in current node dot children, and then for that, now we're going to check if I dot name is equal to destination. What's wrong here? What is wrong? Oh, sorry. I'm forgetting Python myself. Okay. Is equal to destination. We're gonna just print that we found it, and we're also gonna return out of it. Return true. Work on my typing skills. Okay, so now that's done, but what if we don't find this? So we're going to create an else. Else, we're going to just check. We're just going to call search again. Now with I as our current node and destination as the same. Okay. And then once that's, oh, what? Good. Once that's the same, I had no clue what happened. Once that's the same, when that's done, we're just going to return. We don't need to return right now. Okay, so it'll just return until it finds a destination. So now let's just call search down here. Search, and we're going to give A as our current node, and then D as our destination. And actually do dot name here, so that instead of just doing the string format, we'll make a node so we can find stuff. It'll look nicer. So let's just run this. Probably get some error, hopefully not, and let's see what our result is. Okay. So it found two different paths, so which is good, and that's what we wanted. So the first path must be A, B, C, D, and our second path would be A, C, D. Okay. So now that's done. Let's now print out a path. Cause think about it, like what'll be the use if we just have a huge nodes instead of just 4, and not know the path. The path is very important. Okay, so let's do the path now. Okay, I just need to take a quick break. So now we'll actually create a path and print out the path. So what we'll do is we'll create a variable here called path, and that'll just be an empty list. And now for the for search, we're gonna create path, and up here we're going to create just L as our path. So if we found it, obviously we would need to append I, because that's our destination. And if it's not the destination, we will still append it because that will be one of the cases for the path. So now let's append the L dot append I here also. So now let's onset done. Instead of returning true, we'll return L, and also when it exits out, return L. Okay, so now path should just be a bunch of objects. Now we can't really like print path, it'll just be a bunch of objects. So we need to iterate through path. So for P in path, print P dot name. So that will create that'll print out all the names of the nodes it traversed through. Let's run that. Oh, I forgot to give L here. My bad. Let's print that again. Okay, so it found the path, which was it left out A. Okay, we'll just print A. We'll just do that later. You can do that. So it just went to B to C to D, and then the second path, which starts here, I don't know if you can see it, it goes to C to D. So that was what we wanted, and it's now actually giving us all the paths we need. It's just, it would have been nicer if it was indicated separated. So let's just what if we just append append
It's 2 o'clock.
Will that give us the A we need? I don't really think so. I have no clue. I think it might actually give that, yeah. Oh, no, that's not what we need. Never mind, that's not what we would need. Okay, well, I think I'll leave it off there. Thanks for watching, and bye.